Hello learners, welcome again to the course. So in the last week we have discussed about the descriptive analytics. We have conducted the descriptive analysis on two of the columns of the data set. So our data set was the test data set where we have done the descriptive analysis on number of publication and the number of citation. Then we have seen about the how we will calculate the central tendency and the measure of dispersion in R, and we have also seen that how we can analyze the Bradford law and the Lotka law in R. So in this week, what we will be doing is we will be discussing about the structure and dynamics of the knowledge. Basically, we will be talking about science mapping, what exactly science mapping is and what are the different its components. Science mapping is an emerging area comprises of scientometrics, citation analysis, visual analytics, data minings and knowledge discovery. Presently, a wide variety of science mapping tools are available, and few of them we will be discussing in this course. So in this week, we will be discussing about what science mapping is, what exactly the network is, and how we can analyze those networks. We will also do create some of the networks in R. So in science mapping, we represent the structure of knowledge using some visuals, also known as graph or networks. It shows relationship between different subjects, sources, topics, institution and countries, and the relationship between them. Okay. It has various application, like it helps in answering various questions like who are the influential institution or countries on a research on certain topic, or who are the authors have expertise on the certain topic. Also, it helps in understanding the emergence of the discipline and interdisciplinarity of the trending research and many more things which we will be discussing throughout this week. The main aim of science mapping is to explore the structure and dynamics of the scientific knowledge. Various methods have been proposed to study the different dynamics of scientific knowledge. Like some of the popular techniques of science mapping are co-citation analysis, co-word analysis, keyword co-authorship analysis, etc. So before going ahead, let's first see the data what we have extracted from Scopus, and we will try to understand that what we have already discussed and where we can apply the science mapping techniques. Okay. So in the previous week, we have already taken up this quantitative analysis of publication and citation, where we have counted the publication and citation. So we have done this column. Also, we have done this column of the data set. Then we can also use these three columns to analyze based on our previous week. Like we can count the length of the papers. Okay. So whenever we download the data from different bibliographic data sources, these details are given, but sometimes if any of the details are missing, like if page count is missing, so we can easily count. So we can easily just what we do, we will just 1022 minus 993. So these are the simple arithmetic operation, and then we can count the length of the paper, and based on this analysis we can find out that what paper is the most lengthy paper in that particular source or that particular domain. Then we have already discussed that this is the default column whenever we download the data, so this is not to be considered. Then we can just analyze that the different language documents. So if we are doing the analysis on particular domain, so we can do analyze that what different kind of language documents are published on that particular domain. Then we can do analysis on document type. So we can easily count the number of document types, like what is the frequency of article, what is the frequency of other document type like note, editorial and all. Then here also we can do the analysis easily, that what all documents are in open access, and under open access what are the documents are in green open access, diamond open access or gold open access. So what all data we have which still to be analyzed. Okay, so the first is that author. We haven't analyzed that this kind of collaboration between these authors. Then also we have this title, which is a text data. So this particular analysis I'll be discussing when I'll be talking about the text mining. Then we have this affiliation data. where we can see the collaboration of the different institutions. Then we have this abstract data. So here again we can do the analysis of text mining. So I'll be discussing this when I'll be talking about the text data in the upcoming weeks. And these are the index keywords. Okay, so bibliographic data sources give the two kinds of keywords. So one is author keywords and another is index keywords. So author keywords are the keyword which are supplied by the author during the submission of the article. So whenever like article is published, so there are keywords which are given by the authors. And then the index keywords are the keywords which are identified by the system, and they index that publication under those keywords. Okay, so these are the two data sets which we have to analyze. So a science mapping is a kind of network analysis where we study the network of authors, institution, or maybe the keywords. So networks are everywhere. We live in a kind of network system. We have a network of family and friends. If we define formally a network, it is a structure made up of a connected things. So what these connected things are? These connected things are known as nodes. So for understanding purpose, imagine this is a situation where A is a friend of B. Okay, so friend of B, and B is a friend of C. And C is a friend of A. So this is a network of three friends which are A, B and C. If we see these A, B and C, these are known as nodes, okay, or vertex. Okay. So these are the nodes, and the path between A and B, B and C and A is known as link or edge. So this is what a network is. So take another example where we are aiming to study the industry collaboration of an institution. So A is the first university. Say for example, this is a first university who have collaborated with the industry X. Okay. And B is a university. So B is another university, but B have not collaborated with any industry. So if we see this network diagram, we can easily say that A and X have an edge between them, and hence they are connected with each other. So we can say that A university is collaborated with industry X, but B does not have any collaboration with industry. Okay, there is no edge with either of the industry X or any of the industry. Okay, so we can say that B does not have collaborated with any of the industry. So we have various application of network analysis. Some of are listed here. So anthropologists use network analysis to map relationship within communities, including kinship ties, social hierarchy, and patterns of cooperation. By analyzing these networks, researchers can understand social structure, cultural norms, and information flow within the community. Biologists use network analysis to study interaction between proteins within the cell. Here nodes represent proteins and edge represents physical interaction or functional association. The analysis helps in identifying protein complexes, pathway, and regularity mechanism underlying cellular processes. Social media network analysis is another application of network analysis which is most popular in recent time. So social network analysis is used to study communication patterns on social media platforms. Nodes represents user or account, and edge represents the interactions such as follow, mentions or retweets. By analyzing these networks, researcher can understand information dissemination, influence dynamics and community structures on social media. So network analysis is also used to study the transportation system, including road networks, airline routes or subway system. So here nodes represent locations and edge represent the transportation link. This kind of analysis optimize the transportation infrastructure, assess accessibility and to study urban dynamics. And in the last, this is what our focus of this week, citation and collaboration network in the academic literature. It shows the relationship between individual or organization engaged in collaborative activities such as co-authorship network, collaboration in scientific research. Node represent authors, research institution or research topics, and edge represents collaboration or joint publication. By doing the analysis, we can identify key contributor, research trend, and interdisciplinary collaborations. In addition to the example listed here, it is important to note that network analysis has many more applications across various other fields where researchers and practitioners of diverse domains use network analysis to gain valuable insights into the structure, behavior, and interaction within the network, leading to the informed decision making and impactful interventions. So, why to do the network analysis? So, to understand the structure of a data set, to identify nodes, edge, and patterns of connection between them. Also, to identify the most influential elite player or actor in a particular network. To identify the relationship between entities in the network. Also, to identify the hubs or detecting the community in the network. So, to take the informed decision about the changes across diverse fields, to understand the emerging fields and the knowledge discovery. So, in the last, to get the predictive insights. So, to define the concept of a network, we will be using the concept of graph theory. So, what graph is? It's just a structure of a network. So, to represent the structure, it needs two things. One is vertices, which we call it node, and another thing is edge, the connection between the two vertices. Okay. So, vertices are just nodes, actors in the network. You can say if you are doing the analysis of collaboration of authors. So, vertices will be the institution if we are doing the analysis of collaboration between institution, and edge is a line between those nodes. Okay. So, if we are doing the analysis of collaboration of institution, so what edge will be? So, edge will be the collaboration link between those two institutions or the two authors. Okay. So, there are two kinds of graphs are there. One is directed graph and another is undirected graph. So, in directed graph, it shows the path, but in the undirected graph, we have the edge but no direction. Okay. So, in simpler words, we can say that directed graph is a kind of one-way path, but the undirected graph is a kind of which shows the mutual relationship. Okay. So, let us understand the both by this illustration. So, for directed graph, take the example of Twitter and Instagram follow network. So, you are aware that on Twitter and Instagram, if this is a Mohit and if it follow Mukesh, so that means there is a directed edge between Mohit and Mukesh. But if you know on Twitter and Instagram, it is okay that Mohit follow Mukesh. So, it's not sure that whether Mukesh follow back to Mohit. Okay. So, this is an example of directed graph. Now, we take the example of undirected graph. So, to understand the undirected graph, just you imagine the network of Facebook. Okay. So, if here this is Mohit and again here this is Vijay. So, if Mohit and Vijay are friends on Facebook, so it is sure that Vijay and Mohit are also friend on Facebook. Okay, because it's mutual. They like the if Mohit send the request to Vijay, so Vijay will accept, and after accepting the request, both will have a friends. Okay. So, let us take one more example of collaborative author. Okay. So, if say for example, this is a author Priyanka and this is another author Arvind. They have collaborated on a paper. Say for example, this is a paper A. So, we can say that Priyanka is the co-author of this paper A and Arvind is also co-author of paper A. Or we can say in that Arvind is a co-author of paper A and then Priyanka is also co-author of paper A. Okay. So, this is a kind of example of undirected graph. and we will be doing most of our analysis on undirected graph. So adjacency matrix is used for representation of a graph. It shows the relationship between two nodes. Adjacency matrix is a kind of square matrix where the number of rows and the number of columns are equal. Okay. So if we are saying that there are like n cross n matrix are there, so both the number of rows, that is n, and the number of columns, that is n, both are equal. Okay, and that n is the number of nodes of that graph. Okay. So let's say x1, x2, x3 and x4 are the nodes. So let's say this is x1, this is x2, this is x3, and say for example this is x4. So there is a like these are connected, these are also connected, these are connected, this is also connected. Okay. So for this particular kind of a network, how we will draw the adjacency matrix? So the matrix will be like this. This is x1, x2, x3, x4. Here also x1, x2, x3, x4. So in this matrix, wherever there is an edge, we will write the 1, and wherever there is no edge, we will write the 0. Okay. So to x1 and x1, we will write the 0. Then to x1 and x2, there is a edge, so we will write 1. To x1 and x3, there is a edge, we will write 1. To x1 and x4, there is no edge, so we will write 0. Similarly, to x2 to x1, there is edge, this will be 0. x2 to x3 will be 1. Then x2 to x4, 0. Then in x3, x3 to x1, 1. x3 to x2, 1. x3 to x0, x3 to x4, 1. For x4, there is no edge between x4 and x1, so it will be 0. For x4 to x2, there is no edge, it will be 0. x4 to x3, there is edge, so we will write 1, and x4 to x4, it will be 0. Okay. So this we call it as, this is our adjacency matrix. So let's say that we have a this kind of a data set where we have authors and the paper contributed by them. Okay. So these are the author details, and then we have this title of the papers. Okay. So here we have total number of authors are. So there is one is this author, then this is second author, then this is third author, and then we have this is fourth author. Okay. So there are total number of authors are 4. Now we can represent this by a network graph of 4 authors like Mohit Garg. So we will say that this is Mohit, and then we'll say this is Mukesh, we'll say this is Priyanka, and we'll say this is Vijay. Okay. Now we can say that Mohit Garg and Mukesh Behra have contributed one paper, so they are connected. So there is an edge between Mohit Garg and Mukesh Behra. Then we can say that Mukesh and Priyanka, they have contributed one paper. So we can say that there is, this is the path between Mukesh Behra and Priyanka. Then we have like Priyanka and Mohit have also contributed one paper. So this is also edge between them. And in the last we have one paper which is contributed by Mukesh and Vijay. So this is our network graph. Okay. So what our edge pair is? So our edges are Mohit, comma Mukesh. Then we have Mohit and Priyanka. Then we have Mukesh and Priyanka. And then finally we have Mukesh comma Vijay. Okay. So in undirected graph, if you say Mohit and Mukesh or Mukesh and Mohit, the both are same. Okay. So if I'm saying that Mohit and Mukesh, there is a edge. So if and then I'll say Mukesh comma Mohit. So for this undirected graph, it is same. Okay. So we are showing that there is a mutual relationship. So both are contributed the paper. Okay. So from this we can create the adjacency matrix. So how we will create the adjacency matrix? So we will be like create like this. So here we will write Mohit, then Mukesh, then Priyanka, and then Vijay. Okay. Similarly, here we will write Mohit, Mukesh, Priyanka, and Vijay. Now this will be 0. Now if there is a edge between any of the two nodes, we will write 1. So for Mohit and Mukesh, there is a edge, we will write 1. For Mohit and Priyanka, we have edge, we will write 1. For Mohit and Vijay, there is no edge, so we will write 0. For Mukesh and Mohit, we have this edge, so we will write 1. For Mukesh and Mukesh will 0. For Mukesh and Priyanka, it will be 1. And for Mukesh and Vijay, it will be 1. For Priyanka to Mohit, we have 1 edge. Priyanka to Mukesh, we have 1 edge. From Priyanka to Priyanka, it will be 0. And from Priyanka to Vijay, there is no path. Okay. For Vijay to Mohit, it will be 0. For Vijay to Mukesh, there is a path, it will be 1. For Vijay to Priyanka, 0. And for Vijay to Vijay, it will be 0. Okay. So our adjacency matrix are created. So if we see that we have a data set of this kind of thing. So first we have counted the total number of authors, that is 4. Then we have created the 4 nodes. Okay, the first thing is done. After that we have seen the ages between them. So what are the ages? So Mohit and Mukesh, so this is one age, so we have created one age. Then Mohit and Priyanka, we have created this age. Then Mukesh and Priyanka, we have created this age. And then Mukesh and Vijay, this is one age. So what these edge are? So these edge representing that Mohit and Mukesh have contributed paper 1. Mukesh and Priyanka have contributed paper 3. Mohit and Priyanka have contributed paper 2. And Mukesh and Vijay contributed paper 4. Okay, understand? So this is the whole network. Okay. So now we will create all this analysis in R. So how we will do that? Let's see that. So to do that in R, first we need a package. So that package is iGraph. So if you have not installed the package iGraph, you can just simply run this. So package is installed. Now we will call the iGraph package. Or package is called. So what first thing we will do? We will first define the nodes. So here first we have identified the nodes. So our nodes are 4, and which are those? Mohit, Priyanka, Mukesh and Vijay. So the same thing we'll do in R also. So these are our nodes. So Mohit is one node, Mukesh is one node, Priyanka is one node, and Vijay is another node. And we know how to create that character vector. So we can create this. So this is our nodes. So if I see the value of nodes, so there are 4 nodes are there. Now after identifying the nodes, the next thing what we have done, we have identified the edge. So if you see here, these were the edges. So we have identified the edges: Mohit, Mukesh, Mohit, Priyanka, Mukesh, Priyanka, Mukesh, Vijay. So we will be declaring the edges. So how we will declare the edge? So we will be creating the matrix, and this is an edge. Okay, so it's showing that Mohit and Mukesh, this is an edge. Then Mohit and Priyanka, there is an edge. Then there is an edge between Mukesh and Priyanka, and finally Mukesh and Vijay. Okay, and we will do by n equal to, and we will put the by row true. Okay, n col is basically column. Okay, we have already studied what n col is and what n row is, and then we will see this matrix. Okay, so this is our a kind of edge matrix, that Mohit and Mukesh, there is an one edge, then another edge between Mohit and Priyanka, then the another edge between Mukesh and Priyanka, and the last is edge between Mukesh and Vijay. So now we will be creating the undirected graph. So we have the nodes, we have the edge, now we have to create the graph. So to create a graph, we have this function called graph from edge list, and if I run this, so for this argument is edges, so our edges are already defined, and we will say that directed false means it's a undirected graph, it's not a directed graph. So we will run this and we will assign this to a object, let's say GU. Okay, what GU is? GU is an undirected graph of these edges. Okay, so if I run this, and now if I see the output of this, so it's showing that Mohit and Mukesh, there is an edge. Mohit and Priyanka, this is an edge. Then Mukesh and Priyanka, there is an edge. And the finally Mukesh and Vijay, there is an edge. So technically our graph is created, but we need to visualize it, that how exactly this graph looks like. So what we will do, we will plot this graph for better understanding. So for that we need to call this plot function, and here our object name is GU, and I am using the vertex color sky blue. Size of the vertex means node size, I am putting to 30. So this exactly represent the size of the labels, then the label distance, then this edge color, and then the width of the edge. Okay, and this is I am putting the title, that what exactly the title of that graph, and then the vertex label color. Okay, so the node label color is in the black color. Okay, so if I run this, our plot is this. Okay, so this is what our plot, what we were discussing in, that there is a node Mohit, which is connected to Priyanka and Mukesh. Then there is a node which is connected to Mohit and Mukesh. Then there is a node Mukesh which is connected to Priyanka, Mohit and Vijay. And then there is a node Vijay which is connected to Mukesh only. And what these edges are? These edges are showing that Mohit and Priyanka has collaborated for one paper. Then Priyanka and Mukesh has collaborated for one paper. Then Mukesh and Mohit has collaborated for one paper. And in the last, Mukesh and Vijay have collaborated for one paper. Okay. So our graph is created. So this is how we can create the graph in R. Okay. So here I will be visualizing only the small graphs. For complete analysis on those graphs, we will be discussing in the next week. And then in this plot we can change all those colors. Okay, we can like simply put here either green, then if you see it automatically identified that this is green, or we can say, for example, we can see the number of colors in R. So we can take maybe violet red for violet red for edge color. So I'll put this, and then label color we will have, let's say, turquoise. And if I run this, my graph is created. Okay. Also, we can use here the color codes what we have discussed in the previous week. So we have different color codes, like we can have the hexadecimal code, and we can write here like we can write here hexadecimal color code. This, if I run this, so if you see, these are the label Mohit, so, Priyanka, Mukesh, and Vijay. Okay. So this is how you can plot the graph in R. Now this is what we have discussed about the undirected graph with no weights, but the graph can have some weights also. So let's discuss that the graph with some weights. Okay. So this is a kind of a situation. Here the number of authors are 4. So total number of authors are 4 only. But this time we have total 8 publications. Okay. And so our notes are this Mohit, then this Mukesh, Priyanka, and then Vijay. Okay. If we see the edges, we have edge between Mohit, comma Mukesh. So this is done. Then this is also that only, that edge. Then we have Priyanka and Mohit. So Mohit and Priyanka. Then we have Mukesh and Priyanka, Mukesh and Priyanka, and Mukesh and Priyanka. We have 3 papers, but edge will be Mukesh and Priyanka. Then this is done, this is done, and this is done. And we have this Mukesh and Vijay, and Mukesh and Vijay. So we have this Mukesh and Vijay 2 times, 2 publication. Mukesh and Priyanka, we have 3. Mohit and Priyanka, we have 1. And we have Mukesh and Mohit 2. Okay. So total we have 8 publication. 2 plus 1 3, 3 plus 3 6, and 8. So total publication we have. Total publication we have 8. Now if we see the edges list, so these are the 4 edges. So this is what we have the edges. So if we represent this kind of a data set into this kind of a graph, so some information is missed here. Okay, what that information? These 3, 2, 1, and 2. Okay. So how this problem can be solved? This problem can be solved if we can show this kind of some relationship here, and if we can give some weight to it. So for Mohit and Priyanka, there is only 1 publication. For Mohit and Mukesh, there are 2 publications. For Mukesh and Priyanka, there are 3 publications, and Mukesh and Vijay 2. So what we can do, we will make this edge only this much thickness, but we will just increase the thickness of this edge, and then this is the most thickness edge will be there because it has the most number of publication, and then okay. So now if we represent this data into this graph, one can easily say that for this particular data set, the pair of Mukesh and Priyanka has collaborated the highest number of publication, and what those number of publications are? 3. And who has collaborated the minimum number of publications? Those are Mohit and Priyanka with only 1 publications. Okay. So for this, how we will create the adjacency matrix? It's very simple. There will be edge will be there, the same what we have discussed here. So the edges will be there, but now we will give the weight, and the weight is we will give Mohit and Mukesh to 2, and Mukesh and Priyanka to 3, and then Mukesh and Vijay to 2. Okay. So now we will be creating the weighted adjacency matrix for this example. So it will be, so here Mohit, Mukesh, Priyanka and Vijay, and here Mohit, Mukesh, Priyanka and Vijay. Now from Mohit to Mohit, it will be 0. Mohit to Mukesh, we have 2. Earlier it was we had 1 only, but now because the weight is 2, so here it will 2 will come. Then Mohit to Priyanka, it will be 1. Then Mohit to Vijay, 0. Then Mukesh to Mohit, 2. Then Mukesh to Mukesh, it will be 0. Mukesh to Priyanka, 3. Then Mukesh to Vijay, 2. Then Priyanka to Mohit, Priyanka to Mohit is 1. Then Priyanka to Mukesh, it will be 3. Priyanka to Priyanka, it will be 0. And Priyanka to Vijay, 0. Vijay to Mohit, 0. Vijay to Mukesh, 2. And Vijay to Priyanka, 0. And Vijay to Vijay, 0. So this is a weighted adjacency matrix for this example. So let's now see the weighted graph in R. Okay. So our package, we will call this library. So our nodes, so this we have already created. So these are our nodes. Now we will define the weights to edges. Okay. So how we will create? So for Mohit and Mukesh, there are 2 publications. So we'll assign the 2 weight. For Mohit and Priyanka, there is only 1 publication. We'll assign the 1 weight. So for Mukesh and Priyanka, there are 3 publication. We'll assign the weight 3. And for Mukesh and Vijay, there are 2 publication. We'll assign the weight 2. Okay. And now we will have 3 columns, and by row it will be 2. Okay. If we see the output of this edges, so it's created. So for Mohit and Mukesh, the weight is 2. For Mohit and Priyanka, the weight is 1. For Mukesh and Priyanka, the weight is 3. And for Mukesh and Vijay, the weight is 2. So our edges matrix is created, and these are the weights. Now if I have to create graph for this, we will use the function graph from edge list, and these are our edges. So what exactly these are? These, I am saying that you take these edges. Okay. If I run this, so it's saying that these are the edges, and again I am saying that it's not a directed graph. So if I run this, my graph is created. If I see this, okay. So here the relationship between nodes have been created. Now we will plot this. So how we will plot? We will use this function plot. So here this is our graph. Then this is the color of the nodes. This is the size. Then I am putting the nodes, whatever the nodes I have created. So if I run this, so what exactly we did here is, so if you see in the earlier one, without the weight, we have simply assigned the weight to all the edges. But here, so what exactly this it is calling? If I see the output of this, so it's assigning the weight accordingly between these things. Okay. So this, if you see the thickness between Mukesh and Priyanka, the highest, so this is exactly the 3 is. Okay. So if we zoom it, so if you see this thin line between Mohit and Priyanka, it's showing that they have collaborated less for a publication. But if you see here the thickness between Mukesh and Priyanka, so we can easily say that these are the most collaborative author for this particular data set, and then we have Mukesh and Mohit and Mukesh and Vijay. Okay. So similarly, the way we have changed the color in the previous graph, we can change the color here. Okay. So here, if we want to see this directed graph, how we will do that? So instead of this false, we will write true. And now if I run this, okay, so this is a directed graph. Okay, so this is how we can create the directed graph in R. Okay, so this is about the some of the key concept of the graph. So we have discussed about the directed graph and undirected graph, and we have also seen how we can assign the weight to the edges of in the graph. So now we will discuss the some of the key measures in the network analysis. So one is that in centrality measure. So some of the common centrality measures are degree centrality, betweenness centrality, closeness centrality, eigenvector centrality measure. Okay. So degree, betweenness and closeness centrality were proposed by the Freeman in 1970s and related to unweighted network. So let's first discuss the degree centrality measure, and then I'll discuss about the betweenness centrality and the closeness centrality measures. Okay. So degree centrality basically count the number of edges between the nodes. Okay. So basically it helps in knowing the number of connection a node has. Okay. And it shows the popularity of the node. Okay. So say for example, so this is our graph we have already discussed. So what this is Mohit, then this is Priyanka, then this Mukesh, and this is Vijay. So here Mohit is connected to two nodes. What are those two nodes? So one is this one and another is this one. So for Mohit there are only two connection. Now if we see the connection of Priyanka, so for Priyanka there are two connection. One is with Mukesh and another is with Mohit. So for this also two. Now for Mukesh, if we see the connection, this is 1, 2, 3. So for Mukesh, it has three connection, one with Mohit, one with Priyanka and another with Vijay. And Vijay, it has only one connection with Mukesh only. Okay. So if we see here, Mukesh has the highest degree of centrality. Okay. Because it has the highest number of connection in the network. So we can say that Mukesh is the influential node in this particular network. Okay. Also, we can normalize this degree of centrality measure. So how we normalize? So we just simply divide the degree of centrality by n minus 1. N is the number of nodes. So if we count the normalized degree of centrality for Mohit normalize, it will be 2 upon 4 minus 1 equal to 2 by 3. So it will be 0.67. Now if we count for Priyanka, the normalized will be 2 upon 3, 0.67. If we see Mukesh, for 3 upon 4 minus 1, 3 upon 3, 1. And then Vijay, if we 1 upon 3, it will be 0.33. So if we see here, again Mukesh has the highest normalized degree of centrality. So now we will see this computation in R. Okay. So how we will do that in R? So this is our nodes. Then we can define our edges. So these are edges. And then we can create a graph. So we are creating an undirected graph. Now if I see the degree of this. So for Mohit 2, Mukesh 3, Priyanka 2, Vijay 1. So if I see here on our analysis, so Mohit 2, Priyanka 2, Mukesh 3 and Vijay 1. Okay. So now if we calculate the normalized degree centrality, so we will do like this. Under degree function, we will call that normalized is true. So if I do like this, so for this Mukesh, this is a 1 normalized degree centrality, but for Mohit and Priyanka 0.66 and for Vijay 0.33. So the same we got it here. Okay. So this is about the degree centrality measures. So now we will discuss about the betweenness centrality measure. So betweenness centrality measure is based on the shortest path. It shows the nodes that form the bridges between other nodes. So to calculate the betweenness centrality measure, the formula is centrality measure of a node is, say for example, we are calculating for node X, okay, in a graph, it will be so what this is total number of shortest path that passes from A to B. Okay, and then what this is the total number of all those shortest path that passes from node X. Okay, so let us understand this within our example. So our example is this: we have this node Mohit, we have another node Priyanka, we have another node Mukesh, and we have another node Vijay, and this is the edge. Now if we have to calculate the betweenness centrality measure of Mohit, so what we have to do, we have to calculate the path between Priyanka and Mukesh, Priyanka and Vijay, and Mukesh and Vijay. Now the shortest path between Priyanka and Mukesh is this. There is another path from Priyanka to Mukesh, that is this path, but this is a long path compared to this, because here Priyanka has to move to only one step, but here two step. Similarly, for Priyanka to Vijay, this is the shortest path, one step this, one this, so total two step. And if we go by this way, so already Priyanka has to move two step here, so for this it will be three step. So these are the two shortest way for Priyanka. So Priyanka to Mukesh, and then Priyanka to Vijay is via Mukesh. And another path between Mukesh and Vijay, this is the only shortest way. Mukesh can also come via Priyanka, then Mohit, and then Vijay. It will be a longer way. So this is the only shortest path, but none of these shortest path passes through Mohit. So betweenness centrality measure of Mohit is 0. Now if we calculate in similar way betweenness centrality of Priyanka, so we need to see the path between Mohit and Mukesh. Mohit and Vijay, then Mukesh and Vijay. So we see the shortest path for Mohit to Mukesh. So this is the shortest path. Then to Mohit to Vijay, this is the shortest path. Mohit go this way, this will be lengthy way. So here also there is no path where Priyanka is coming in between. So betweenness centrality measure of Priyanka is also 0. Now if we calculate the betweenness centrality of Vijay, so if we calculate the betweenness centrality of Vijay, we have to calculate the path, shortest path between Mohit and Mukesh, then Mohit and Priyanka, and then Priyanka and Mukesh. So from this graph we can easily see that the shortest path to Priyanka and Mukesh is this one, to Mohit and Priyanka is this one, and to Mohit and Mukesh is this one, and nowhere Vijay is coming in between. So the betweenness centrality measure of Vijay is also 0. Now if we calculate the betweenness centrality measure of Mukesh, so we need to calculate the shortest path between Mohit and Priyanka, then Mohit, Vijay, and then Priyanka to Vijay. So for Mohit to Priyanka, there is one path, but Mukesh is not coming. But Mohit to Vijay, this is the only shortest path. Okay, and this is the only path is there, and Mukesh is coming in between. And between Priyanka and Vijay, also Mukesh is coming. So the betweenness centrality measure of Mukesh is 2. So we can say that the betweenness centrality measure of Mukesh is the highest, and other three has the 0 betweenness centrality measure. Mukesh has the more connection in the network. So let's see this computation in R, how we exactly calculate the betweenness measure in R. So to calculate the betweenness measure in R, we have this function betweenness, or if I run this, so you can see that for Mukesh the betweenness is 2, for others Mohit, Priyanka and Vijay it's 0. Okay, it's very simple. Now we will discuss about the third centrality measure is closeness. So similar to betweenness measure centrality, we have the another measures which is closeness centrality measure. So it exactly find the nodes that are closest to all other nodes in the network. The closeness score helps in identification of the expert influence in the network. So say for example, again we'll go with our graph. So to calculate the closeness centrality measure, we need to first calculate the shortest distance between one node to all other node. Then the closeness centrality measures will be the inverse of the sum of all those distances. Okay. So we will count the closeness centrality measure for each of the our node. So for Mohit to Priyanka, if you see, for Mohit to Priyanka, it is one step. Mohit to Priyanka, the shortest distance is one step. There is another way, like if we go like this, Mohit to Mukesh and Priyanka, there is a two step, but the shortest is one step is directly connected. Then for Mohit to Mukesh, we have one step, and for Mohit to Vijay, we have two step. So because after moving first step will reach to Mukesh, and then the second step is Vijay. So it's two step. So closeness centrality measures of Mohit will be 1 upon 1 plus 1 plus 2. Okay, that is 1 by 4. So it will be equal to 0.25. Okay. Now we will calculate the closeness centrality of Priyanka. So Priyanka. So for Priyanka to Mohit, one step. For Priyanka to Mukesh, one step. For Priyanka to Vijay, so if we count closeness centrality for Priyanka, it will be 1 upon 1 plus 1 plus 2. It will be 1 by 4 equal to 0.25. So now if we count the closeness centrality measure for Mukesh, so for Mukesh we have Mukesh to Priyanka, one step. Mukesh to Mohit, one step. Mukesh to Vijay, one step. Okay, and if we count the CC Mukesh, it will be 1 upon 1 plus 1 plus 1 equal to 1 by 3, which is equal to 0.33. Now if we count the closeness centrality measure for Vijay, so for Vijay to Priyanka, it is 2. For Vijay to Mohit, it is 2. For Vijay to Mukesh, it is 1. So CC for Vijay will be 1 upon 1 plus 2 plus 2. It will be 1 upon 5. It will be 0.2. Okay. So here if you see that Mukesh is again has the highest closeness centrality measure compared to the other 3 nodes. So if you see Mukesh has 0.33 of centrality measure, then Mohit and Priyanka has 0.25, and then Vijay has the least centrality measure of 0.2. So what it means is that Mukesh is well connected in the network. It is connected to others nodes, and then Vijay has the least centrality measure. So we can say that Vijay is the least connected in the network. It has closeness centrality measure of 0.20, and the other 2 nodes have the same closeness centrality measure. So they are equally connected. Okay. So there is another measure known as eigenvector centrality measure. Okay. So this eigenvector centrality measure was given by a sociologist named as Phillips Bonsis in 1987. Okay. So what exactly it calculate? So it does not only consider the connection between the nodes, but also see with which these nodes are connected. Okay. So let's see an example. So say for example, this is the case here. Priyanka, then this is Mukesh, Mohit, this is connected to Vijay, this is Zuckerberg. Okay. Now here if we see that both Mukesh and Priyanka have the degree centrality of 3. Okay, because Mukesh has 3 connection with other nodes. So one is this one is this one is this one. So it has 3 of degree centrality measure. Then same with Priyanka, 1, 2 and 3. But if you see here, Priyanka has one influential connection with Zuckerberg. Okay, so this from here we can conclude that Priyanka is more influential compared to Mukesh. So this is what eigenvector centrality measure is. It captures global influence of the nodes that focus not only on quantity but also on quality. So one of the famous application of eigenvector centrality measure is PageRank algorithm. So let's see what PageRank algorithm is. So have you ever imagined that how Google works? Okay, how when you just simply enter the some keywords in the search bar and Google retrieve the results, and then after retrieving the result, it rank those all results. Okay, so how exactly it does? So it basically compute this page rank algorithm based on which it order the number of pages in a results. Okay, this page rank algorithm was given by these two people, Larry Page and Sergey Brin. Okay, so they are the founder of Google also. So what they did, they computed the ranking of the web pages using this algorithm. Okay, and they presented this computation in the 7th worldwide conference held in 1998. Okay, so in PageRank algorithm, the rank of a web page is not computed just based on the link, but the normalization of all the links are done by measuring the importance and number of outbound links to the neighboring pages. Okay, so let us understand the PageRank algorithm with an example. Okay, now consider this is an example. Mohit, then we have here Priyanka, then here we have Mukesh. Okay, so you consider that Mohit has cited Priyanka. Okay, just you consider that Mohit has cited Priyanka in their paper. Okay, then Priyanka has cited Mukesh, and Mukesh has also cited Priyanka in their paper. Okay, and then Mukesh has cited Mohit in the one paper. Okay, so this is one kind of a citation network where graph is made based on the how they have cited. So this is how they have cited. Now to calculate the page rank of a node, what we have to do, there is a formula. So this is the formula of page rank of a given node. So what exactly it is? It is a the page rank of the node from where the input link is coming, and these are the leaving nodes. Okay, let's calculate the page rank of all the 3 nodes here. Okay, what we will do, we'll make the table like this, that Mohit, then Priyanka, then Mukesh. So at the first iteration, we will assume that the rank of all the nodes are equal. Okay. So what we will do, we'll make that there are 3 nodes are there. So we'll give the 1 by 3 here, 1 by 3 here, 1 by 3 here. Okay. Now, if we have to calculate the page rank of Mohit, what it will be? It will be from where the link is coming in input link. So input link is coming from Mukesh. So page rank of Mukesh divided by the leaving node to Mukesh. So what exactly the page rank of Mukesh? So this was the page rank of Mukesh, the old rank. So 1 by 3, and number of leaving nodes to Mukesh is 2. So one is this LM and one is this LM. So it will be 2. So it will be 1 by 6. Now if we have to calculate the PR of Priyanka, so it will be PR of Mohit by L of Mohit plus PR of Mukesh by L of Mukesh. Why? Because Priyanka is getting input from Mohit also and then input from Mukesh also. Okay. So Priyanka is cited by Mohit also and Mukesh also. So now we will calculate PR of Mohit is 1 by 3 and the leaving nodes are 1. Then PR of Mukesh is 1 by 3 divided by 2. So it will be 1 by 3 plus 1 by 6 equal to 2 by 2 plus 1 by 6. So it equal to 3 by 6, 1 by 2. Okay. So rank PR of Priyanka is 1 by 2. Iteration 1. And the rank of Mohit is 1 by 6. What will be the rank of Mukesh? So for Mukesh, it will be PR of Priyanka, then L of Priyanka. Okay. So what exactly PR of Priyanka? 1 by 3 divided by, then leaving nodes to Priyanka only 1. So it will be 1 by 3. So this equal to 0.16, this equal to 0.50 and this equal to 0.33. So from here we can say that Priyanka has the high page rank value compared to Mukesh and Mohit. Then Mukesh has the second highest page rank value. Then the Mohit has the least page rank value. Okay, and our highest page rank value is for Priyanka. Okay, page rank. So this is just an example of how we compute the page rank of the nodes. But here I have concluded the page rank based on just one iteration. But we have to take many iterations for calculating the page rank with the accuracy. Okay. So when we will be analyzing a huge data, so it will be quite difficult for us to do the analysis through manual way. So we have to use some software. So in R we can do easily. So we'll see how we can easily calculate the this page rank of these graph. Okay. So this is our graph. So what I am saying is that, so these are the edges. So there is a edge between Priyanka and Mukesh, then Mohit and Priyanka, then Mukesh and Priyanka, and then Mukesh and Mohit. Okay. So I am considering this as a edges. So we will create the graph, and this time we are creating a directed graph. So this is how we'll do. So our graph is created. So we'll see the graph. So it's saying that there is a edge between Priyanka to Mukesh. So if I'll see here, there is a edge between Priyanka to Mukesh. Okay. Then I am saying that Mohit to Priyanka, Mohit to Priyanka also. That is okay. Then we have another edge, Mukesh to Priyanka. So we have Mukesh to Priyanka. There is a edge. Then we have the edge Mukesh to Mohit. So we have the edge from Mukesh to Mohit. Okay. So this is our graph. So let's visualize it. So I am just visualize it. So this is my graph. So if you see here, the double arrow between Priyanka and Mukesh is showing that this Mukesh has cited Priyanka and Priyanka has cited Mukesh. Okay. But if you see between Mohit and Priyanka and Mukesh and Mohit, there is a single arrow link. So what exactly it is showing? That Mohit has cited Priyanka and then Mukesh as cited Mohit. So to calculate the page rank, what we will do? We have this some simple function page rank GD. So GD is our graph, and if we do compute this, our page rank is calculated. Okay. So page rank for Priyanka is 0.39, for Mukesh 0.38, and for Mohit is 0.214. So this is what we have also got. Our value was not this, but this was the case that Priyanka has the highest page rank value, then followed by Mukesh, and then in the last Mohit. Because here lot many iteration is already done. Okay, but we have done only one iteration. So this is an example of page rank algorithm. So in this lecture, I have discussed about the concept of science mapping, then how we can do the science mapping using the network analysis. We have discussed about the different kind of networks. We have discussed about the directed network, then undirected network. Then we have discussed about the centrality measure to map the strength of a network. We have discussed about the centrality, degree centrality measures. Then we have discussed about the betweenness centrality measure, closeness centrality measure, and in the end we have discussed about the eigenvector centrality measure, and we have taken the example of PageRank algorithm. Okay, so this is all about this first lecture of this week. In the next lecture I'll be discussing about the some of the technique of science mapping, that includes bibliographic coupling, co-citation analysis, co-authorship analysis, and then co-word analysis. Okay, so see you in the next lecture. Thank you.